Guys, in this video we're going to be discussing some methods for finding the equation of a line. That is, we know some things about the line, maybe it goes through a certain point or has a specific slope, or we desire it to have a certain slope, but we want to find its equation. So, we've gotten kind of used to going from the equation to the line. Let's get used to now going from the line back to the equation. Before we begin though, I kind of want to discuss one primary fact about this. We're going to be using this formula. It's called point-slope formula. That looks like that. Okay, maybe I shouldn't cover up that bottom part of that X there, but I just real quick want to kind of elaborate on where we get this formula in the first place. It's going to help us find the equation of a line. But point-slope formula, remember that slope we define as rise, okay, over run, or change in y values with respect to change in x values. How far it goes up compares to how far it goes over. But recall from the last video concerning slope that we say change in y values, delta y over delta x here, okay? But delta y, change in y values, delta x is the difference in the x values. We said, what if we took both sides of this times this denominator, delta x, okay? Delta x, which is just a number. We said that these would necessarily cancel, and what we'd be left with is delta y, or change in y values, is equal to the slope times change in x values. Of course, change in y values, change in x values, that's kind of like we said y2 minus y1 is our change in y values, y2 minus y1. And we said change in x values is x2 minus x1. That's how we obtain it. You'll notice up here that I've written this formula, and this is precisely what follows from manipulating the slope formula. This is no more than a different kind of look at the slope formula. We kind of manipulated it. So here's the deal, folks. Point slope formula, okay? It gets this name for a very, very simple reason. I'd like to say it's because mathematicians are very unoriginal in naming things, but we don't want to be kind of ambiguous. We want to be straight to the point. But we say point slope formula. I can tell you this. You can find the equation of any line so long as you know two things. A point on the line. You notice I said a point. I don't care which one, just some point on the line, a solution pair, and the slope of the line. Okay, so if we know these two things, it's nice because we can use that point. We'll call that point. You'll notice this formula looks a little bit different than what the slope formula is with y2 minus y1. You'll notice it just says y minus y1 and x minus x1 because we're going to leave this x and we're going to leave this y general. That is, we're not going to put in numbers for those. Okay. So the three values that we're really looking for here are some point on this line, okay? So x1, y1 is what we need. We need a point on the line. And then those two values are going to go here, okay? And then we need a slope m is what we need. M, wow, that was an ugly m. And that number is going to go here. So really, three values are what we're looking for. But first things first, if you're watching this video, you ought to pause it, really, and write that down, that formula right there, or at least burn it into your brain, okay? So let's go ahead and use it. I mean, let's not dilly-dally here. Let's go down here to this first example right here. We'll call this example, okay? But example number one, what we want to do, say, is necessarily find the equation of a line passing through this point 1, -2 with a slope of m equals 3. The first thing I want to point out is this. This is an awesome problem because we already have an x and y that are easily substitutable, if that's a word, into this formula, and we also have a slope that we desire, okay? You notice I said desire. We could make this any slope we like. In this instance, we want a slope of 3, which means this ought to be going uphill. But first things first, let's go ahead and do this. Let's illustrate this. We're not beyond sketching pictures, but we say 1, -2, and of course, like any good math student, you should label your points 1, -2, and that was very poor for a math teacher. We say 1, -2, and a slope of 3. So a slope of 3, of course, that's a ratio of rise to run. So we'll proceed to go up 3. 1, 2, 3, okay, and over 1, and drop in a second point here. And you can see that this line's going uphill. It's rising much more than it runs. And I should label this with its equation, but I don't have one yet. So let's find it. All right, let's do it. So here's my suggestion. If we're going to be substituting in, if you bring your eyes back up here, for this y1, this m, and this x1, which we know all of these, the number one thing I kind of ask people to do is this. Let's go ahead and draw on a template. Let's just put our blanks in. We want these things here, and And if it helps you to see it a little bit better, here's what I'll do for you. I mean, whoops, we don't want zoom. We want, we want a different color. So our y1's going to go here. The y value of our point is going to go there. Our slope's going to proceed to go there, and then our x value is going to go here. So we had an x value of 1, so that's going to go in this, actually this second spot over here. We had a y value of -2. That's really important. That's why I ask us to put in these parentheses, because we're going to be dealing with a double negative here. And a slope of 3. You can even write 3 over 1 if you're bored. The first thing I want you to notice is this. We're going to simplify this out, but this double negative here is going to proceed to produce a sum. But we say now we've got y plus 2 on the left. And on the right, it's one of my favorite properties, we're going to distribute this 3. So we say 3x, and a positive 3 times a -1, of course, is -3. But if I want the equation of this line, naturally, a lot of us like to isolate y, put it in slope-intercept form. So let's go ahead and kick this 2 from both sides here. We'll subtract 2 from the constants of both sides, and those cancel. Goes faster with sound effects. So we say 3x, and this is -3, and a -2 is -5. Now, first thing I want to point out is this. I didn't draw out this whole picture over here, but if I had some graph paper, you'll notice here that -5, that would be our y-intercept, and it's really feasible. If you're looking at this, you know, if I try to stretch things a little bit here, yeah, right there, it's reasonable that we have a y-intercept of -5, okay? And you'll notice the slope here is still 3. We asked that to be true, okay? So a really convenient formula, and you know, the nice thing about the name is it kind of tells you what you need. You need a point and a slope. So let's go ahead and take a look at this second example over here, example number 2. A good one to write down in your notebooks or whatever. But let's find the equation of a line passing through the points 1, 2, and 3, 4. And just got done saying all we need are a point, singular and indefinite, mind you, and a slope. Here's the interesting thing about this one. We have points, we have plural points, okay? And we have no slope. So the fact of the matter is this. It doesn't matter which point we pick here, but we're gonna need to find a slope for this. So let's do a couple of things here, starting with sketch a picture of what's going on here. So we have 1, 2, right there, 1, 2, 1, 2, and we want 3, 4. So 3, 4, right, yeah. So 3, 4, here's our line. Obviously, we should have a positive slope when we complete this here, but check this out. We can determine slope with fingers and toes. Nothing wrong with this. If it's a convenient example, you'll notice it went to the right 2, and it went up 2. So this is a slope of m, is a rise of 2 over run of 2. That's positive, and it's a positive 1. Okay, so this is a very basic slope. Okay, but let's say we had some really ugly points, and I don't like to call them ugly. I do enjoy fractions, but maybe some severe decimals. What we can do is we can fall back on our slope formula that we have, you know, conveniently written right there. Kind of an ugly box, apologies, but we say, okay, so slope is 2 over 2 is 1. We can count this, we can draw a picture, but let's say I had ugly points. I don't want to draw a picture. It's kind of hard to tell, whatever you got going on. The necessary thing here is this. Given our 2 points, we're going to have to explicitly state the slope as a difference quotient, if you will, but changing y over changing x. So delta y, what we've got here is we've got 4 minus 2, 4 minus dos, and then changing x values, which was a change between 3 and 1. Okay, and again, I know this is pretty Mickey Mouse, but you might have some uglier points. The cool thing is, hey, we've got a slope. The slope is 1, and we have points. Remember we said points, more than 1. So here's what I'm going to do. I'm going to make a suggestion. You can take it for what it's worth, but to put this into our point slope formula, which means we need, y minus y1 equals m times the quantity x minus x1. Let's go ahead and put in our slope of 3. And let's pick a point here. It doesn't matter which one we pick, but I tend to go for the most convenient. That is, I would go with 1 and 2 because it's, you know, it's just smaller in magnitude. The thing to be careful of here, though, is this. If you're plugging in the point 1, 2, the y value is 2, and that needs to come first, okay? And our x value is 1. So check this out. Let's go ahead and work this one out. We have y minus 2 on the left. We have distributing the 3. We've got 3x minus 3, and adding 2 to both sides. Check that out. Very similar to the last example. We got 3x minus 1, okay? So 3x minus 1. You know, I didn't draw the picture very well. I do have to kind of excuse myself on that there. But the fact of the matter is this. We have now our slope-intercept form of this line, which is where we're at, if you're asking me. So, good math to you.